qualitative analysis of cations using sodium hydroxide.
Hello students and welcome. I like keeping my promise, and I promise to bring to you the qualitative analysis of cations using sodium hydroxide. In my previous upload or video, I took you through what happens if you add aqueous ammonia to solutions containing metal ions. So for today, we want to analyze the 9 cations I had before using sodium hydroxide. So again, I have calcium ions, or a solution containing calcium ions. I have another one with magnesium ions. I have another one with aluminium. And then I'm working with another one, zinc ions in solution. The other one has lead-2 ions. On the other side, I have another one with iron 2 particles, another one with iron 3 particles. Then I have another one with copper, and finally I will add sodium hydroxide to a solution containing barium. So today I'm using sodium hydroxide. Yes, sodium hydroxide. And I will add one at a time, as I did before. So in the first case, this is a solution containing calcium ions. I will add, and you can see a white precipitate has been formed. A white precipitate, remember, like I did in the previous video clip, I'm adding excess of sodium hydroxide and the precipitate remains. Then I have another one with magnesium ions. So I'm adding few drops. Yes, a faint precipitate there. Yes, you can see. Now the precipitate is very clear. A white precipitate has been formed. I can add excess. I can add excess of sodium hydroxide, and the precipitate persists. Yeah, the white precipitate will just persist. Just to be sure about this magnesium, good, the precipitate remains. Next is a solution containing aluminium. So a white precipitate, it is. Then I add excess of it. Good. So you can see what has happened. The white precipitate has dissolved. With aluminium, the white precipitate has formed with a few drops. Then in excess, it has dissolved. Then the next is zinc. Zinc, again, you can see some white precipitate forming with a few drops of sodium hydroxide. Yes, the white precipitate is there. So I can add excess. With excess, the white precipitate has dissolved. That is again with zinc. The next one has lead-2 ions. You can see a white precipitate, very clear white precipitate. I can put excess. I add excess of it. You can see what is happening to the white precipitate. Yeah, good. The white precipitate has dissolved. The white precipitate, when I add excess of sodium hydroxide, the white precipitate has dissolved. That is with the lead-2 ions. We go on with another solution containing iron 2. With iron 2, the very same thing. Green we observed before with aqueous ammonia. So the green precipitate there, that is very much insoluble. That is a green precipitate. Another solution here containing the iron 3 particles. So if you're keen to observe, a brown precipitate has been formed. A brown precipitate has been formed. If I keep adding and I add excess of it, good, a brown precipitate that is insoluble has been formed. That is when you put excess of sodium hydroxide, the precipitate does not dissolve. So this one has copper-2 ions. Copper-2 ions. So you can see blue precipitate. Blue precipitate have been formed. Even when I put excess of it, I add excess of it, you can keenly observe that the blue precipitate persisted. The blue precipitate persisted. So that is with the copper-2. Then I have another one with barium. So with barium, good, observe that one. Good, the precipitates are there. The white precipitates are there. Let me add excess of it, and I can even shake, and the precipitates are still there. Yes, I can confirm the precipitate did not dissolve. So again, what has happened? Another very interesting chemistry has taken place. We've added with the magnesium, barium, and I even had calcium. Yes, all of them white precipitate that was insoluble in excess of sodium hydroxide. But I have three cations that forms a precipitate that dissolved. That is zinc, lead, and aluminium. Basically because the three hydroxyl are amphoteric in nature. And if they are amphoteric in nature, it means they will dissolve in excess alkali, that is excess sodium hydroxide. Good. Now, if I use sodium hydroxide and aqueous ammonia for analysis, remember now in this case, sodium hydroxide will be for the preliminary test, then aqueous ammonia will help me to confirm. So together, we use them for qualitative analysis of cation. In addition to others, like I can introduce the sulfate ions in form of sodium sulfate or sulfuric acid. I can introduce chloride. I can introduce the carbonate, etc. And basically what I'll do in the next section or the next upload that I'm doing for qualitative analysis, I will get you a sample question whereby I'll have an unknown or a sample of unknown substance. Then we do an analysis to identify the cations present in the unknown sample. Otherwise, thank you so much. Do not forget, this concept will be so much covered in paper 3, chemistry paper 3, question 2 or question 3 there. Good, and I'm pleased to keep teaching you, and I know you're getting to understand more and more. Thank you so much for watching.
Okay, for the ionic questions, we have the ionic question that will give us an insoluble white precipitate, the calcium hydroxide, magnesium hydroxide, and barium hydroxide. Even in excess, they cannot dissolve. Then we have the one that would form white precipitate that will dissolve in excess sodium hydroxide. These are amphoteric hydroxide, like the zinc hydroxide that will dissolve in excess sodium hydroxide to form the complex that we call tetrahydroxyzincate ions. Then the aluminium hydroxide will dissolve in excess sodium hydroxide to form the tetrahydroxyaluminate ions. With lead-2 ions, they will form lead-2 hydroxide that will dissolve in excess sodium hydroxide to form what we call the tetrahydroxyl plumbate ions. The other colored ions that forms precipitates that are insoluble in excess sodium hydroxide, like the ion 2, it will have the green precipitate. Ion 3 will have brown precipitate, and copper 2 will have the blue precipitate. In order, you can see like the green precipitate for ion 2, it's ion 2 hydroxide. Then ion 3, it is ion 3 hydroxide, the brown one. Copper 2 hydroxide, it's also blue in color. So thank you so much for watching. Do not forget to come back for more. Thank you.